Basically, when brainstorming the project idea for this innovation contest, we knew we had to capitalize on Rutgers' large-scale construction plans in the next 10 years. Looking at President Robert Barchi's strategic plan, we found that he called for the construction of 6 new academic buildings and 3 new residential buildings over the next few years. We knew this had great potential for energy innovation because an idea that requires large-scale infrastructural changes in existing buildings is always less implementable than an idea that can be implemented before the construction of buildings. So what we found as the ideal project proposal idea was borehole thermal energy storage, which essentially is an underground thermal energy storage technology that can be implemented under the buildings to massively reduce energy consumption, the carbon footprint of Rutgers. My colleague Mathew will talk more about that.
So how do boreholes work? Boreholes are dug several hundred feet into the ground, where each hole is filled with a polyethylene tube connected by a U-shaped piece at the bottom. And inside these tubes, there's a water or glycol-filled solution, which acts as a thermal conductor during the summer months to bring heat into the ground and store it in the ground where there's a loss of only 2% over 6 months. During the winter, this process is reversed where the heat is now taken out of the ground and can replace heating systems and heat up the building, and thus returning the ground back to a cold temperature, where we return back into the summer again, where the whole process recycles over and over and can repeat indefinitely for the lifespan of the building. So during the summer, once again, heat goes into the ground and just reverse it. This replaces both heating and air conditioning. Cost and savings analysis of this project can be explained by Joseph Wu.
So for the cost analysis, we based our project on a similar project at Richard Stockton College. Approximately, they spent $5.1 million implementing this borehole thermal energy storage for about 150,000 square footage. So initially, for the first step we would have to do was scale it up to the size of Rutgers. So we calculated the gross square footage for all 9 buildings, which came out to be about 1.3 million. But since the borehole thermal energy system would go under the building, we calculated the base, the square footage of the base, and therefore it came out to be 212,000 square feet, and that cost about 1.3 million, 11.3. So for the annual savings analysis, Richard Stockton, the consumption was about 500,000 square footage to heat the building. And for Rutgers, it was about 1.3 million square footage to heat the building. And we calculated to be about $1.44 million of savings. And that was equivalent to 15.1 million pounds of carbon emission that was reduced.